Welcome, everyone. So I'm going to talk about foreign packages in Gnu Guix. And this is a talk I prepared together with David Thompson, who couldn't make it this time. So what is Gnu Guix to me? You know, you've heard of a lot of people by now. And for me, there's a holy grail. You know, I'm a software developer, and I want a controlled environment. Right? I want it to be predictable, which means that I want to control the full dependency graph. Yeah, and to explain this is that when you write a piece of software and you give it to someone else, and he files a bug, he says, you know, something is wrong with what you've written, and I have to ask him, you know, what distribution are you using it on? You know, what package manager did you use? What, you know, if it's a Ruby gem, what gem version did you use? What Ruby did you use? What gems did you install? Right? It's impossible. Yeah. So the holy grail is that you write a piece of software once with all its dependencies, and you can reproduce it at any time. Yeah. So I can reproduce it on somebody else's machine. Exactly the environment that I'm using to run this software myself. It's a holy grail. I mean, how many of you are developing software? Right, so you know about this problem. The other thing which is really important is that I want to understand what is happening, even on my system. Right? So what are foreign packages? Really, non-native Guix packages, we call them. You know, like Perl has CPAN, Python packages, which have been a straight nightmare from the start. Ruby gems, which did all right for a while, but if you're doing Ruby development, you know that it's not all that rosy now. R has its own system. I'll get to that in a minute. But actually, Emacs has its own packaging system. Firefox has one, right? So any tool that wants to install software locally is a foreign package manager. So there's a lot of them, yeah, and actually a lot of these solutions are written because the underlying distribution, software distribution, doesn't do the job for them, right? So for Firefox, if you want to install a plugin, you know, they could have used Debian, but they didn't. So Ruby gems I'm going to treat specially as an example because I'm very familiar with it, and I wrote the implementation together with David for Guix. So what does a Ruby gem actually do? Yeah, the gem tool, if you say gem install package, yeah, it does it by default in the somewhere in the global system, somewhere in user local, whatever. Which is not the desired behavior unless you're a system administrator and you want to share it with other people. The alternative is to define an environment variable called gem home, or pass it on the command line, which will put it into a local directory. And the same for Python, the same for R and all that. They have this system. And there are some issues with that. Yeah, for example, gems are based on major number versioning of Ruby. Right, so if you have a Ruby 2.0 installed on your system, 2.0.1, the gems will be installed in a path, something like, with a version extended, but it's capped at 2.0. Right, so if you upgrade your Ruby, to 2.02, the gems will be installed in exactly the same directory. So the underlying Ruby can be different, but you're sharing the gems. Okay? And you see this solution in a lot of systems, including Pythons. And why is this? I honestly don't know. Yeah, it's a convenience. It's a convenience for the Ruby developers. Yeah, they think that if they don't have a major number upgrade, that you can actually share the gems without problems. That's what they think, but there's no guarantee. So gems are not isolated, not even between Ruby's versions. And what has happened is that there's a whole stack of tools that has been built on top of Ruby, which tries to deal with this. So we have Ruby VM, RVM, which actually overrides gem home and installs packages. It installs actually Ruby itself locally, yeah, so in your home directory, and then the whole tool stack on top of that. Yeah, so RVM tries to isolate Ruby. That's what it does. Yeah, so it tries to help. RBEnv is a similar solution. And then Bundler is a tool which actually starts from the source. So if you have a source tree, you run Bundler inside it, and you say to Bundler, you know, I want for this particular source, I want to run this combination of gems. It will install them inside your source directory. As a developer, I got to dislike RVM and Bundler with a passion. Actually, I spend a lot of time fixing issues around RVM and Bundler, which I'm not supposed to be doing. You know, I was writing software. That was the fun of it. And virtual env in Python is a very similar solution to RVM and Bundler combined. So how do you solve this mess? Well, working on Gnu Guix, I realized that we could do something. So we wanted to build support for Ruby inside Gnu Guix. Yeah, and so you support foreign packages. So we started simply with gem home, overriding gem home. Yeah, so that's what I realized. If you override gem home, you can isolate the gems for this particular Ruby. So you have Ruby in the store, right, in the GNU store. You install it through Gnu Guix, so that you got the GNU store, then the hash value for this particular Ruby, and then the version, and then Ruby -v, and it will give you this one. So this is a nicely recent Ruby. That solves already one thing, because if I'm running Debian, I always end up with old Rubies. So what I do basically in my home directory, I override gem home, and I include this path, the Ruby store, and just force all the gems that I install for this Ruby, they are forced really in this directory, in my home path. And then I tell Ruby to use its gem path, right? So you need two variables. One is for installing the packages, and one is for telling Ruby where to find it. And now I can do gem install, and it installs it in this directory, and I can run it. Works perfectly. And it's perfect isolation, because if I change the Ruby, if I put another Ruby in the path, I can again override gem home and gem path, and they'll be completely isolated from each other. Yeah, as a software developer, this already is nirvana. Life got so much better. It works. Yeah, so I'm working with a reproducible modern Ruby for development. I have no need for RVM, RBN for Bundler whatsoever. Gem works fine. Gems are isolated. Bundler still works if you insist on using it. I don't. It works for me. But I'm not happy. And why is that? Because I've got two hats. I'm a programmer, but also a system administrator. Yeah, and in the real world, we need system-wide deployments. And they need to be reproducible also, right? And we want full control of the dependency graph, because what I did, I don't have full control of the dependency graph. Yeah, if I install two gems after each other under the same gem home, what actually happens? You know, and the order of installing gems also matters. So I'm tracking my own time. So why did you do that?
I'm also tracking your time.
Ah, thanks. So 10 minutes left. Good. So ultimately the point you derive at some, you decide, okay, gems need to go into Gnu Guix, right? I can, if I want to do system-wide deployments and I want to give it away and put it on servers, it's not going to work if I'll do this all in my home directory. So together with David, we started adding Ruby gem support to Guix. And it wasn't the first support of a foreign build system, because Python was already in there, R was already in there. So I'm going to skip the code walk itself, but there's actually 4 files involved. One is called Guix build system ruby.scm, and it defines what a package should be like, right? So before, in the other talks, we've seen package definitions, and most of them were around the GNU build system. So we have a Ruby build system now, yeah? And the Ruby build system has a certain layout for its package definition, which differs from the GNU build system, because we can override certain things that gems want or that Ruby wants. Yeah, so we've defined new variables for our package definition, yeah, and that's contained in there. Yeah, so if you put a value in your package definition which doesn't belong there, you will get an error. Yeah, so the different build systems have different definitions. Then you have got Guix build Ruby build system.scm. Yeah, and that actually does the unpacking and building of the gem in this case. Yeah, so it fetches a gem, it unpacks it, and it installs it. And then we have Guix import.ruby.scm, which actually gives you a Ruby package definition. It looks like this. Yeah, so Guix has a native command called Guix import gem, and then I add the gem name, right? And it will just on standard out spit this out. Okay, so this is actually the package definition itself, and you can see here that it has a build system named Ruby build system, and the downloaded version is a Ruby gem URI. So it actually fetches it directly from Ruby gems, and it calculates the hash value of the downloaded package. Basically, you're done. Right? You can just say gem, import it, boof, and then install it. It's as easy, pretty much as easy as using gem install itself. Then there's a last file which is called GNU package ruby.scm. And this file actually, since it's in the GNU package directory, it contains the Ruby packages themselves. And there's a long list of them. I think there's over 100 packages now, 100 gems that have been put into GNU Guix. So where are we now? You can say Guix package -I install Ruby log4r. Yeah, so that same package definition that you saw here, we added to the Guix tree, and now we can simply install it. And it installs the package into the store, so in /GNU store, then the hash value Ruby log4r, and since it's a gem that only contains a lib, it adds a lib directory. Okay, and when somebody, one user on your system types Guix package -install ruby.log4r, it will create also automatically the symlink. Yeah, so in the default Guix profile, lib ruby gems 2.2.0 gems, it will link to this library. Okay, and the Guix store is immutable, and it's versioned. Actually, all the things that define the package ultimately result in this hash value. Is that yours or mine? Now it gets confusing. So we've got 5 minutes left. So now I need to tell Ruby, the Ruby that's running in your path, where to find this gem. Yeah, and it actually, you just need to add this one, gem path. And this gem path is actually suggested by Guix itself. So if you say Guix package -- search paths, it will list you the paths that are relevant for the system, and it includes the Ruby path with the gem path. So if you add this, Ruby from that point on knows how to find these gems. And I can just run it. Yeah, so Ruby -e require log4r. Done. We have a fully reproducible Ruby. We have a fully reproducible gem. We can write it once and deploy it anywhere. For Python, it's pretty much the same story. Yeah, so you can list the Python packages. I think there's 250 now, in that order. You can install a Python package. And for Python people, this is very important, because Python eggs, setup, it's never worked that well. There are at least 3 package module managers. And when you do a Guix import, like I did with Ruby, it will give you a package definition straight from PyPy, which is the package repository for Python. And really, Guix will install anything as long as there's a setup.py in there. And I think it always works, right, Ricardo?
Works for me?
Yeah, it always works. Yeah, so actually the Python people should be really happy now for the first time in history. There's something that consistently works. Yeah, but also, what is also great is that we can do a package definition which is actually easily scales to either Python 3 or Python 2. Yeah, so if you have a Python package defined, a Python module, basically using this import, you add a line saying define public Python 2 parse datetime, package with Python 2, so it uses the Python 2 interpreter, 2.7, and then you say Python parse datetime. Now you get two packages on your system. One is the one that will install with Python 3, and the other one will install with Python 2. The first time I saw this, it basically blew my mind, but I'll come back. So R is a very similar story. You can import directly packages from CRAN, and you can also import them directly, thanks to Ricardo's work, from Bioconductor. And R is a bit of a success story in the sense that its package management has been pretty great. And they put a lot of testing in there. And people are really happy because when you install R and you use these packages in general, they just work. But there's one caveat. R modules are tied with the release of R. Yeah, so if you have a certain version of a module, it actually belongs to a certain version of R. Now, what happens when you want to have different version of modules that actually require different version of R? You go straight to hell. Yeah, and in Guix, R modules are not tied to R releases. They're independent of each other. So to recapture, 2 more minutes, really. Well, we've covered this. Quickly, the difference with Debian. Unlike Debian, versioning of packages is not a problem in Guix. Multiple tasks is not a problem. So if you have an Apache that you want to install with SSL or without SSL, you basically get 2 Apaches. And you can run them both at the same time. Yeah, same for Ruby. You can run R with BLAS linked into it, or Atlas. Yeah, you can just do that because everything is strictly isolated through the SHA value in the path. So foreign imports are easy. You can just, if you have a foreign input system and you write a build system to support that, you can quickly create these packages. The only dependency for Guix itself at this point is the Linux kernel API. So glibc is actually not, everything glibc is in the graph, but you can actually have different versions of glibc running on your system and build the tooling on top of that. The only thing that you consistently need to reproduce binary packages is a single kernel API. Fortunately, it doesn't change that quickly. What about Docker? With Docker, people may not realize, but when you build a Docker image, the time and order of software installation matters. You get different outputs. Yeah, so the build of the Docker image itself is not reproducible, and you don't actually know what's in there until you start looking. And why do you send multiple gigabytes of data around just for a simple thing, maintaining a package? Docker comes with file system and network policies. It's pretty crazy, And at what level should we care about these things? I don't think we should care. Yeah, so this is for the Twitter sphere. You must be mad to use Docker when there's Gnu Guix available.
So, is Gnu Guix available for anyone?
Yes.
Docker is available.
Yes. Yes. I think it's still. Is it alpha still? We're beta. We've actually transitioned from alpha to beta. I'm not sure it was on the website already. And I think we will go very quickly to stable. And actually, Gnu Guix has support for containers also. Yeah, so you can actually, unlike a Docker container, which is several gigabytes, a Gnu Guix container can be as small as a few kilobytes. And you have the exact same functionality. Thank you.